This topic is most suitable for students in Form 1. So it is topic number 3, and it is the topic on force. Now in this topic, we are going to look at several concepts. The first one is the definition of force, or a description of force, followed by the SI unit of force. And here I'll be not just mentioning that the SI unit of force is the Newton. Will describe the method in which we state SI units of derived physical quantities and basic physical quantities. We will look at effects of a force, and then we are going to study the various types of forces. There are about 10 forces. And then finally we are going to look at the vector nature of a force and close the topic by looking at the relationship between mass and weight. So let's go straight to the first part, which is the definition of force. Now, what is a force? You have probably heard this word being used all the time, but in science, it has a particular kind of meaning. Now, it's not possible to get an object like this and then we say that this is force. It's not possible to do that. In other words, a force is not something which is tangible. It's not an object. It can only be described by what it does. For instance, you have seen a person out there push something, maybe push a car which has stuck in the mud, or lift an object, or even pull something. We say that these people are applying a force. This is very important. Forces can only be described by what they do. So at this particular level, we won't bother so much with the definition of force, because a force is usually defined if we state its effect on the momentum of an object. And that concept will be learnt later on when we look at Newton's laws of motion. It is from the second law of motion that we define force, and hence go ahead and give a definition to the SI unit of force, which is Newton. At this level, because we have not learnt about momentum and other concepts that enable us to give a clear definition of force, we are simply going to settle for the description of the term force. And if we are asked what is a force, we will say that a force is either a push or a pull. When you push an object, you are applying a force. When you pull an object, you're also applying a force. So remember, a force is described from the effect it produces on other objects. Another concept which I want us to get clear right from the word go is that a force is always applied by something on something else. Forces do not work in isolation. For example, if we are talking about a car that has stuck in the mud, it is the person who is pushing who is applying the force on the car. So the force is applied by the person, and that force is applied on the car. I'm trying to emphasize this concept here, that a force is applied by something on something else. So when you are talking about forces at this particular level, be very careful to mention which agent applies the force and on which agent. In other words, which is the agent that receives the force and which is the agent which applies the force. Very important. So remember that a force is either a push or a pull, and that a force is applied by something on something else. Now at this point, we realize that force is a derived physical quantity. We have already encountered the distinction between basic physical quantities and derived physical quantities. There are 7 basic physical quantities, and I hope you can remember them. They range from mass, time, length, electric current, thermodynamic temperature, amount of substance, luminous intensity, and all that. There are 7 basic physical quantities, and in physics it is important that you recall these 7 basic physical quantities. Now, any other quantity which is derived from these 7 basic physical quantities, from other derived physical quantities, is referred to as a derived physical quantity, because it is obtained from other physical quantities by either multiplication or division of these other physical quantities. So, force is one of these derived physical quantities. But at this moment, I won't show you how the force is derived until you study Newton's third law of motion, and that one will be in Form 3. So let's settle for the fact that force is a derived physical quantity, and its SI unit is referred to as Newton. At this point, we are going to see how we write this unit, the Newton. I'll take you to my blackboard so that we can be able to see how we write this unit, Newton. So remember, we have defined the term force, or described the term force as either a push or a pull. And then we have said that a force is applied by something on something else, trying to emphasize the fact that we define or we describe the term force by the effect that it produces on something else. That is the only way we can be able to describe force at this particular level. And then we have gone ahead and stated the SI unit of force as Newton. Now let's go to my blackboard so that we can further describe some of these concepts that I've already talked about. Now we have already stated that a force is either a push or a pull, and stated that the SI unit of force is Newton, and Newton is written like this. When you want to write the unit in full, like for example, you can say that the force is 20 newtons. Or you can say, in short, you can write 20 N, like that. Now notice how I write this unit, newtons. I start with lowercase n when I write the unit as a full word, but when I abbreviate the unit with letter n, it becomes capital letter N. This is what happens with SI units, which are names of scientists or names of people in general. The Newton, this applies to units such as joules, which is the unit, the SI unit of work. Let's say maybe the work done is 100 joules. You will write it as 100 capital J, like that. So when you write the unit as a complete word, you will start that word with lowercase letter. But when you write the unit as an abbreviation, then you start the abbreviation with uppercase or capital letter. That's all there is to this unit, 20 newtons or 20 N. Remember that. Very, very important. Now let's look at the main points that we've been able to learn in this topic. We've already seen that a force is defined as either a push or a pull. So if in an exam at this level you are asked to define the term force, you will just say that a force is either a push or a pull. Usually you are asked to state the SI unit of force. You'll go ahead and say that the SI unit of force is Newton. If asked to write the unit as a complete word, then you will write it like this. But if asked to abbreviate, then you will the abbreviation with uppercase N. Of course, it is important to note at this point that force is a derived physical quantity, just to distinguish it from basic physical quantities. In our next lecture, we are going to look at types of force.